Hello everyone, welcome to the next lecture in Theory of Computation, and in this lecture we will be seeing some more examples of NFA and see how to design NFAs. Alright, so let's get started. Alright, so here's we have an example. L is a language which is a set of all strings that starts with 0. So our task is to design an NFA which accepts the set of all strings that starts with 0. So if you recall, you may know that we have designed the same thing using DFA in our previous lectures. So in this lecture we will be trying to design those same examples using NFA. Alright, so let's see how we can do this. So before starting, what will be the set of all strings that starts with 0? What will be the elements in this set? The elements would be like 0, 0, 0, 0, 1, 0, 0, 0, and so on. It is an infinite set, right? Now let's see how we can design the NFA. As usual, we always start with the starting state. Let me call it state A. A is my starting state. I will represent it using this arrow, which means it is the starting state. And I need to send it to the next state, which I will call state B, on getting input 0. On getting input 0, I send it to state B. And my only condition is that it should start with 0. So start A is the starting state and the first input is 0. So if the first input is 0, I go to the next state B, and B should be my final state. So I'll put a double circle around it. Why? Because I just want the string to start with A, and after that I don't care what it is. In B, whatever you get, 0 or 1, let it stay in B itself. Alright, so here I have completed my NFA. Is it complete? If it was DFA, we could have seen that it is not complete because we did not mention what happens to A if it gets input 1. But here I did not mention it. Why? Because this is an NFA, and in NFA it does not matter even if you don't mention that. This is a complete NFA. Now let us take a few examples and see what happens. Let me try to pass a few strings. Let me say I'll pass this string 001. So as usual, I should always start with the starting state, which is my state A. And A, on getting input 0, where does it go? It goes to state B. It goes to state B. And what is my next input? My next input is again 0. So B, on getting input 0, where does it go? It goes to B itself. It goes to B itself. And what is my next input? My next input is 1. And when B gets the input 1, where does it go? It goes to B itself. And now I have reached the end of the string. And at the end of the string, where am I? I am in state B. And is state B the final state? Yes, it is the final state. So this string is accepted. Alright. Now let's take another example. In this example, let me test for the string 101. So I start always with my starting state, which is A. And A, on getting input 1, where does it go? On getting input 1, A does not have a place to go. So it goes to phi. I will represent it by phi. A does not have a place to go. It does not go anywhere. So this kind of configuration where a state does not go anywhere, that is known as a dead configuration. Dead configuration. Right? Okay, but in case of DFA, we did not have a dead configuration. If we leave a DFA like this is incomplete. We have to mention where A goes even if it gets input 1. So let me just convert this into a DFA. If I were to convert it to a DFA, I would send it to another state called state C on getting input 1, and after coming to state C, it stays in state C whether it gets input 0 or 1. So from this state C, if a string comes to this state C, it does not have any way of going back to this final state B anymore. So in case of our DFA, this state was known as the dead state or the trap state. Dead state or trap state. But in case of NFA, we don't need to mention this dead state or trap state. We just leave a NFA blank just like this. And this shows that it is a dead configuration and it is a complete NFA. So this is how to design a NFA for the set of all strings that starts with 0. Okay, now let's see another example. Construct a NFA that accepts sets of all strings over 0, 1 of length 2. So if you remember, we have done this same thing for DFA as well. So let us see how to construct the NFA for this. So before starting, here our input symbols are 0 and 1, and our language, what will be the sets of elements in our language? It is the sets of all strings over 0, 1 of length 2. So what will be the sets of all strings of length 2 over 0, 1? They will be 0, 0, 0, 1, 1, 0, and 1, 1. Okay, now let's see how to construct the NFA for this. It is very simple. First I start with my starting state, which is state A, and then A, on getting input either 0 or 1, either 0 or 1, I send it to state B. And at this point, what is the length of my string? The length of my string is 1, right? I just got one input. Now on getting the next input, whether it is 0 or 1, I send it to the next state, which I will call state C. And at this point, what is the length of my string? The length of my string is 2. I got my first input here, second input here. So the length of my string is 2. So this C should be my final state or accepting state, right? So this is it. This NFA is complete. So if it was a DFA, I should have sent it to another state here, which will be a trap state or a dead state on getting a next input on state C. But in NFA, I don't need to do it. I just leave it like this, showing that this is a dead configuration, means whatever I get after this state C, it does not go anywhere, so that will be rejected. So let us just take two examples quickly and see how does this work. So let me first check for this string 0, 0. It should be accepted. So let's see, it starts from state A. On getting input 0, where does it go? It goes to state B. And on getting input 0 again, this is the second input, I'm in state B, and on getting input 0, where does it go? It goes to state C. And now I reach the end of the string, and where am I? I am in state C. And is C the final state? Yes, so this is accepted. Okay, so now let's take another example. In this example, I will take the string 0, 0, 1. Now, should this be accepted? This should not be accepted. Why? Because the length of this string is 1, 2, 3. And the NFA should only accept strings of length 2. So let's see whether this should be accepted or not. I start with my starting state A, and the first input I get is 0. So on getting input 0, where does A go? A goes to B. And what is my next input? My next input is 0. So on getting this 0, I'm in state B, and on getting this 0, where does B go? B goes to state C. And now I have the next input 1, and C on getting input 1, where does it go? C on getting input 1, it has no place to go. It does not go anywhere. So we represented it with phi, means C does not go anywhere. So at the end I am at phi. So this string is not accepted. Alright, so those were the examples of how to design two simple NFAs, and I hope it was clear to you. So thank you for watching, and see you in the next lecture, where we will be seeing more examples.